Hey, what's going on, everybody? Isaac here, Civil Engineering Academy. I'm excited today about our podcast episode. If you haven't liked us or subscribed, please do so and share it with a friend. We love getting the word out about Civil Engineering Academy. And also, you know what? If you're preparing for your exams, we're obviously here to help you on your journey to pass those. So if you need to pass your FE or your PE exam, go check out our resources at civilengineeringacademy.com, where we have exams. We have practice problems that are free right here on our YouTube channel if you're listening to this on YouTube. And we also have courses that will help you ace those exams, and we love sharing them. So definitely check those out. But today I bring on Professor Tyler Ley. He is a professor at Oklahoma State University, and he's a concrete nut. I don't know how else to put it, but he loves concrete. I have followed him on YouTube. He's got a wonderful YouTube channel. You should go check it out. Really passionate about concrete, has a great personality. I love the vibe that he has on the channel. And, if I was a student and still going through school, I would probably try to take a class from him because he just makes a topic very enjoyable. We talk all things concrete, everything to deal with concrete, where concrete is now, where it's headed, how to question the processes of things, and really how we as engineers can help improve concrete and its lifespan, its durability, making it cheaper, more sustainable, all the aspects of concrete where we can improve. It's the most used product, outside of water, that we use everywhere. And it's good stuff. So we talked all about it. I really enjoyed this interview, and I think you're going to enjoy it too. It's with Tyler Ley. It's coming up right after this. All right, Tyler, what is going on? Thanks for joining me on the Civil Engineering Academy podcast. It's good to have you.
Thanks so much, Isaac, for having me. I'm super excited to be here and share whatever I can with your audience. It's going to be fun.
I love it. So we kind of connected for those listening. Actually, my brother Mark heard you at one of these conferences. I can't remember which one, but he thought you would be a fun guest to have on the show. I know you've got a real passion for concrete, and you teach. So could you give us, I guess, a little bit about your own background into civil engineering and how you dived into concrete, how you got into that world?
Sure. I grew up in Oklahoma, and I was an undergraduate at Oklahoma State University. And when it was my sophomore year, I still remember there was a guy that came to visit named Bryant Mather. He's one of the epic concrete people. He was at the Army Corps of Engineers, and he gave a talk at the ASCE meeting that night. And all the good students all went to the ASCE meetings to catch up and see what all's going on. And Bryant Mather gave this amazing talk, and like the hair on the back of my neck literally stood up for like 3 days. All right. And I was freaked out. I just thought I was just enamored with concrete. Then I took my first concrete class, and it was awesome. And it was love. I just fell in love with how simple it was, how flexible it is, but yet how complex it is, like simultaneously, and how much good it does for people every single day, and how much we don't even realize how much good it's doing for us. Like, I bet you couldn't have lived your life today, at least not at the same level that you did, without concrete. And it's the second most used commodity in the world. It's unbelievable, right? Just unbelievable. So
I love it. Well, I love your energy and your passion for this. I do think it's a neat subject to talk about, because I do think that even engineers, but most people in general in the public, just have no clue why this is such a neat material and how often it's used and where it's used as part of their daily life. So I guess why, in your opinion, is concrete the greatest material on the planet? Is there a couple things outside of that?
Dude, that's easy. It's rock, it's sand, it's cement, it's water. It's stuff you can dig up in your backyard and make. And then to make cement, you have to like cook rock and sand, but you can dig up rock and sand pretty much anywhere. And you make this stuff that can last generations. You make this stuff that can help your kids, help your kids' kids, help all your neighbors, make their lives better. Oh my gosh. And it's just simple. And it costs 5 cents a pound. 5 cents a pound. What else can you think that last generations that helped so many different people that only cost 5 cents a pound? But I'll tell you, the complexity of concrete is unbelievable. For something that we use so much, there's so much that we're still learning, so much knowledge and tools that we still need. And I think it's awesome. And it's so also tied into, just how the industry works and how the business works and how people pay for it and fund it and build with it. I mean, there's so many bits and pieces and sides to it that it's just every day is a great day, baby. You get to learn
That's,
even more.
I love
I love it.
So 5 cents a pound, that's cheap. Has it not gone up at all
Yeah,
with
I
the
think
times?
yeah, I think we're talking in really unique times right now, right? And it,
Yeah.
it it might have gotten up to about 6 cents a pound, all right. But I don't think it'll be too much longer before it goes down again, all right. But
Wow.
5 cents a pound is pretty amazing. I mean, if you compare to steel, it's more like $1 ish a pound. You know what I mean? And if you compare to fudge, my favorite thing to compare concrete to, fudge tastes much better, and it costs around. Well, it used to cost around $12 a ton, $12 a pound. Now I think it's more. It's more up to like 15 or so, or 16. And that's an international study there on fudge.
Wow.
But yeah, I mean, it's just fun to kind of benchmark these things. And fudge tastes great, but I wouldn't want to drive on it. You know what I mean? I don't know about you, but
No, yeah, I don't want to drive on that either. So, that's awesome. So, where do you see the future of concrete heading? What's out there? What are things looking like for concrete?
yeah, sustainability is going to be is and is going to continue to be a big focus for concrete.
Mhm.
Concrete produces 5% of the world's CO2, and a lot
Mhm.
of people they just stop right there. And what we need to say is, as civil engineers, what we need to say next, as a public, is, do you know why? Do you know why it produces 5% of the world's CO2? It's because it's the second most used material on the
It's
planet.
everywhere.
It's everywhere, ubiquitous. I mean, producing water, just clean water. It produces about 10 to 15% of the world's CO2, depending on what numbers you actually look at. 10 to 15% of the world's CO2 is spent making clean water. We never complain about that. Why?
Mm-mm.
Because it's essential. I reckon
Well,
concrete's pretty similar. It's essential. We need it, but we need to make it better. So don't ever, I'm not saying that it's good enough. I'm not saying that. I'm
yeah.
just saying that there's a reason why the carbon footprint is as large as it is. And there's going to be a massive, massive amount of work. I'm doing a lot of work on it. There's a lot of people around the world doing a lot of work on it to make it better. And we're chipping away and making it better and better and better all the time, reducing the amount of actual CO2. And the secret is reducing the amount of clinker. That's what comes out of a cement kiln.
Hmm.
Producing the cement is really, I mean, the cement is about 90% of the carbon footprint, or the binder, the cement plus the
Mhm.
other things we put in, is about 90% of the carbon footprint of concrete. So anything you can do to reduce the amount of cement that makes that concrete better. But if or makes it better for sustainable reasons, and also sometimes can make it perform better as well. I know people say, no, don't take the cement out. But if you know what you're doing, you can make long lasting, great performing, some of the best concrete on the planet by removing cement.
Wow.
It's pretty awesome. Yeah. And but if we can do things to make concrete more durable, I'm a big fan of that. If I can make it last longer, yeah, it's going to cost CO2. But if I can make it last 60, if I can make it last 200 years long, I mean, that's money, that's CO2 well spent. You know what I mean?
Yeah.
And I think that's what we need to be focusing on. So I've got a lot of work I'm doing to make concrete more durable. We've got ways to measure fresh concrete when you're just making it, to measure to make sure that it is going to last that long. Like, how in the world would you ever do that? Well, one thing that's a problem is the amount of water in concrete. Making concrete is kind of like making Kool-Aid. If you make the Kool-Aid too dilute, you know what I mean, right? I
Oh
mean, I
yeah.
think it just doesn't taste right, right? It's just like, blah, you know what I mean? And having too much water inside concrete is the same thing. It dilutes the cement grains. It moves them further apart. It actually makes it less strong, and it actually makes it easier for outside chemicals to penetrate, and so it doesn't last as long. So we have a new technique that we actually developed that measures the amount of water in fresh concrete. It's called the Phoenix. And we've
Ooh.
known that this is a very important parameter for like 100 years, and there's no established method to measure it. Isn't that insane? Isn't that
Really?
totally insane? When you write down a mix design and you say, oh, a 0.45 water to cement ratio, there's no way to measure that in the field. They say, oh, batch ticket size. Well, batch ticket's a good guess, but there's ways water can find its way into the mix sometimes, and this is a test to help with that. There's other things like um, air bubbles in concrete. Like air, why would I put air in concrete? Air isn't very strong, but air bubbles are actually the key to freeze thaw durability, to making sure that when that concrete gets wet and freezes. I know Utah, that's a big deal there.
Oh, yes.
Yeah. And so we got to make sure we get the right
Salt
air void
too.
structure. Oh man, salt's a big deal too. We got to make sure that we get the right air void system. It's not just about volume; it's about the air void spacing. So we've actually developed tools that can measure that, and these things are being used by people in the field. So I try not to just talk about stuff. I implement stuff. I get it out there, because changing the industry is how we truly make change for the future. We can talk about things and draw things on, pieces of paper, but really changing our specifications, changing our practices. That's how we make an impact. And I'm all about impact, baby.
Well, I love it. And those are things you're doing at the university that you're implementing out in the field.
That's right. That's exactly right.
It's like your own little playground over there then.
Oh man, I've got a 35,000 square foot concrete playground that I get to work with every single day. Man, I live, breathe, sleep, dream concrete, man. That's what I'm all about. I'm all about making it faster, better, cheaper, more durable, more sustainable. That's my mantra every day.
And how do you generate the ideas for like maybe what you want to experiment or test on? Is that coming from students, or do you have a book of ideas you jot down all the time and hey, let's try this out and see where it goes? Or how are you generating some ideas on how to make it faster, cheaper, better, more durable?
Yeah, excellent question. So I go to a lot of conferences and I meet a lot of people and I ask a lot of questions and I listen to what a lot of people say. I've also been in this industry. I worked in this industry as an engineer. I was a contractor. And I got so much stuff that I learned. And there are so many problems that we need to work on. And you can take that two ways. You can see that as, oh my God, we have so many problems. Or you can see it as like, baby, we got work to do. And every problem is an opportunity. And that's the way, I look at it. But truly, Isaac, to solve a problem, you have to have somebody that's interested enough in it to fund it. Does that make sense what I'm saying?
Yes.
Like someone that it's a big enough issue to them that they're willing to put the money up to try to make an impact on it, to solve it. And so I get grants from like the federal government. I have a big grant from FAA right now. I have a big grant from DOD grant right now, where all of them have big problems that they're trying to solve, and they want my help to solve them. So they fund my students, they fund the testing, they fund the research. We do more than $1 million a year out of my group in research every single year to try to make the concrete industry better. So it's awesome. I do have a lot of ideas, but sometimes it's not the right time for an idea. I hope that makes sense what I'm saying. Yeah. Sometimes you have to wait until things are set up. So I just get lucky that I get to do so much great stuff. And I get so lucky that I get to work with so many great people. I've got an amazing group around me. My students have great ideas, and it's so much fun to work with them. And I always say I help build tools, but I help build people to make the concrete industry better. And that's what I get excited about. So thanks for asking the question.
I love it. And it sounds like you're making a big impact there. So that's really awesome. I was thinking about the question and the comment that we talked about earlier about this being how much CO2 is emitted. And you said a lot of times as engineers, we just kind of leave it there. And I was thinking, shouldn't maybe another half of that conversation be what kind of energy efficiencies that we're getting from the use of concrete, because we are using it everywhere.
That's right.
And maybe what that does in terms of savings on, generation or power or things of that nature, where it all kind of trickles down into other industries. So, have you looked into that or talked about that topic as well?
Yeah, I think the key is to figure out that we use our materials in the right way for the right application. And concrete, pound for pound, is one of the most sustainable materials on the planet. It's just that we use so much of it. That's why the carbon footprint is so large. So if I'm doing like a concrete sewer pipe, or a sewer pipe in general, I mean, there's not that many other things that can even remotely compete with it. There's a few. There's a few, and there's some that are up and coming, and we need those up and comers. We need new ideas. We need competition. That's what drives people to get better and better and better again and again and again. But yeah, I mean, for sure, that goes back to the durability thing that I was telling you about before. If you can make a material that can last a long period of time, I mean, you don't have to rebuild it. You don't have to repair it. You don't have to go back to it. If you can make a material that insulates really, really well, and you can design concrete to be extremely insulative, then that's super helpful as well. So you just have to figure out. No, I wouldn't want to use it for a window. You know what I mean? I wouldn't want to use concrete for a stent in my heart or something like that. You know what I mean? So I'm not saying it's everywhere. I'm just saying I think it's amazing. So
that's awesome. I think one of the fun things you have a popular YouTube channel talking about all things concrete, and in a couple of your videos, you talk about baby aspirin, what baby aspirin is for concrete. Could you just describe what you mean by that?
Sure. So baby aspirin is like that medicine that you take a really small dosage of that does amazing things for you. That like a baby aspirin for your heart. It just makes your blood run better, and so we need things like that inside concrete, because if you get heavily medicated concrete, heavily chemical concrete, it causes all kinds of side effects, just like medicine and us. So we've been focusing on using things like shrinkage reducing admixtures, SRAs, but using them at about 1/3 to 1/4 the typical dosage. So what that means is it reduces the amount of cracking, the amount of shrinkage cracking. Again, Utah, a lot of, that's another story, my friend. A lot of cracking there. And you can do it without having other side effects. Like, it doesn't affect your strength that much, doesn't affect your cost that much, and it doesn't affect your ability to entrain air that much. So another one out there that I love is fibers. So macro synthetic fibers, I'm a big fan of. They are fibers that are usually about 2 inches or so long, that are made out of plastic. Those are the ones that I like the most, but there's steel ones out there that are good as well. And when you mix them into concrete at a low dose, something like 4 to 5 pounds per cubic yard, then what they do is they're not so much that they make the concrete hard to handle and hard to consolidate and actually finish, but you would not believe they reduce your crack sizes by about 50%. You're like, wow, how did you know that? Well, we've done a lot of testing with it, tons and tons of testing with it, and we've done it in practice. We've done it. We've helped with Amazons. We've helped with distribution centers. We've helped with overlays on actual highways. So putting this stuff in practice and seeing how it performs, and people are just shocked. They're like, how can that little amount of fiber do that much good? Because I don't even notice it's there. And that's a baby aspirin, baby. That's what we need. We need more of that stuff. So
I like it. I was thinking also, I remember taking courses and studying about concrete and learning about ultra high strength concrete.
Yeah.
Where have you seen that mainly used, and what are some admixtures that you're seeing in those?
So ultra high
baby
strength
aspirin.
Yeah, I don't think ultra high strength concrete has any baby aspirin in it. I think ultra high strength is the regulated drugs is what they use in that stuff. Gotcha. And I'm not knocking ultra high strength concrete. Okay, I'm not. I'm just telling you, it is not your dad's or granddad's concrete. It is a unique beast. It is highly engineered, where they engineer it from a powdered scale, like a powder. They pick certain powder distributions to all pack together. They pick different aggregate distributions to all work together. They use steel fibers in it because if it cracks, it's like super, super brittle, and it uses a lot of cement in it. It is not a sustainable concrete per pound compared to a normal concrete, but But if you can get a lot longer life, if you get 3 to 4 times the life of normal concrete out of it, then that's valuable. So sometimes what people will do in repair applications where they need a very high strength material that is they need to last a very long period of time, that is ultra high performance concrete. If they need a concrete that is very, very slender for some reason, like very, very thin, I've seen it used for architectural finishes. I've seen it used in bridge applications where they just need something really, it's lightweight because the structure is lightweight because they're using less material in it. That's when ultra high performance concrete can be extremely valuable. There's a lot of people that are actually dipping their toe in it in the United States right now, different states that are trying it, seeing if it makes sense. And what by and large they find is that for certain applications, it works great. For other applications, I'm not sure it's quite there yet. And most technologies are that way. They're not a silver bullet that does everything. They do certain things really, really well. One challenge with it is not everyone can make it. For example, normal concrete, it takes around, well, maybe around 10 minutes to add all the rock and sand and mix it up. Ultra high performance concrete, you have to have a very special mixer, not just any mixer. And sometimes it can take 20 to 30 minutes of mixing. Wow. And it's a lot of mixing. And it's actually, Isaac, it's scary. It's scary at first. And it's only scary because it's so different than normal concrete. You mix it up and you're like, oh my God, this is never, what is this? It's never going to work. And then all of a sudden it like it starts going, it starts going, it starts going. You have to add enough energy to actually get the water to leave. To water to not be attached to the powder, and then it starts congealing and turning into something that looks more like Play-Doh, and then it turns into something that's like flowable. But if you keep mixing it, it sets up again. So you have to get in this like special energy range for it. It's like really, really unique stuff.
And really it sounds very difficult to deal with.
Well, and I don't, though, please, if you're an ultra high performance concrete lover, I'm not saying that this stuff is bad. I'm not saying that at all. I'm just saying it's different. And I don't, if you're honest with yourself, I think you'd say that too. So,
yeah. Well, that's good to know. Well, I just wanted to touch on that, make sure. There's some buzzwords out there, and that's one you hear all the time, ultra using that type of concrete. So, well, it sounds like you have a awesome passion for teaching students and what you do. Is there something particular that you love as you teach students about concrete? What is there something that pops in your mind as you're teaching this subject?
Well, I'm gonna give you two answers. One of them, I love to teach about development length, and I don't know if you remember about development length. It's do. How far the bar has to be in before it doesn't pull out, and it's like crazy important. It's not usually taught very well, and I teach it where I say it's just like being a worm. You're like, what? Like the worm. He sticks his head up in the morning to look out to see. Like, you don't want to get ripped out of the ground by the bird, right? So you want that worm to be in the ground far enough, or possibly hooked. You know what I mean? Like a hooked worm, like hooked in the ground so the bird can't pull you out. Or grab it onto your worm friends. That's like a lap, right? The worms all lap together. I don't think worms actually ever do that, but they could. You know what I mean? They could all work together. And so I love to teach it that way, but it's something that's not well understood by a lot of people. I mean, I know I didn't understand development like the first time I had it. And it was just hard. I don't know why it's so hard. It's a simple concept. And so I love teaching it, but I also love teaching people about the practical side of concrete. This idea that why do we do things certain way? There's sometimes that there's not a good reason, but there's very good reasons. And once you put a concrete mix design together, why we do certain things certain ways, why we specify concrete certain ways, just the practical side of life and how it's applied to concrete. For example, if I'm going to size a column, I usually size them in increments of 2 inches, 10 inch by 10 inch, 12 inch by 12 inch. Why? Because that's what forms come in. People love I want 11.57 inch diameter by 11.57 inch, column. I'm like, yeah, no, don't do that. You know what I mean? And they're just, simple things like that. And that's probably not the best example, but that's one example where you need to think about things are done a certain way for a reason. And then you need to test that. Is that a good reason? Most of the time it is. Sometimes it's not. Sometimes it's just the way we've always been. And that, oh, baby, another opportunity for improvement, another opportunity to make things better, or expand, and realize that it doesn't always have to be that way.
Well, I think I'm in the utility industry and transmission design, and there's always an opportunity for improvement on the foundation designs.
Definitely.
You'll have foundations, that can get monstrous,
Yeah.
6, 7, 8, up to 15 feet I've seen. And then embedments that go down to China, 70 feet deep. And so I can see, like, there's definitely improvements in all aspects of construction. I have a question for you. What in your house, do you have anything made out of concrete that you're like,
Well,
I made that because I love concrete, or
that's an
is
interesting
the
question.
whole house made out of concrete? What's going on?
Yeah, I've got that question actually a lot more than you'd think I would. Like, do you have a concrete house? And the answer is I don't have a concrete house. My wife says that we have so much concrete in our life. The last thing we need is a house of concrete. All right, but maybe someday. I'll tell you, just to add on to that, we are working really hard on 3D printing right now,
Yeah.
and we've got a 3D printer that we've built ourselves that uses concrete, uses
Mm,
ready mix concrete, and it prints around rebar. It's not the little mortary toothpastey thing. This is
yeah,
a
I've seen
this is
that.
a much bigger thing. It's super easy. It fits on a skid steer, and you can drive it around. And I'll be making a YouTube video about it pretty soon. But we've actually we want to make affordable concrete homes, and I'd love to live in one. I think it'd be awesome. And
Yeah.
once this stuff is printed, you can't even tell that it was 3D printed. It looks just like a normal formed concrete wall. It's pretty
Wow.
awesome. Yeah, but other stuff, I've built a lot of stuff out of concrete, and I got a lot of stuff in my lab that I'm super proud of, that I've built. But nothing in my home. I've got some really cool cylinders, or concrete samples from different really famous structures, like the
Mm,
I-35W bridge in Minneapolis. You remember the one that collapsed? They built a new one. I've got
yeah.
a good friend of mine, Kevin McDonald. He did the concrete design on that, and he gave me a cylinder of that stuff. And I've got some
That's
other bits and
awesome.
pieces and other things that I'm super proud of. But I don't have a concrete house.
All right. Well,
Maybe
just checking.
someday.
Just
Maybe
checking.
someday.
So, uh, what are some industries that engineers can get into uh, as they learn more about concrete? Is there some pathways that maybe they could be more involved with concrete and that particular subject if they have a passion like you do?
I tell you what, I don't even think they need to have a passion like me. All right. I
Okay.
think concrete is so important that as a civil engineer, you are going to find a way to stand out and be important if you understand it and you have, like, even semi decent understanding of it. And it's so everywhere that you're going to be able to contribute and make things better. That's what I tell my students in my concrete class every single year. But let's dig in a little bit more. Like, let's say you're really interested in concrete, like a concrete freak like me, right? Or not even, just kind of freaky like me. Um, there are jobs in the supplying of concrete. There are jobs in all the additives and all the ancillary stuff for concrete. There's jobs in tools for concrete. There's jobs in designing concrete, in constructing concrete, in
Mm,
like specifying concrete. Man, like, I mean, you can make almost anything out of concrete. You just got to figure out how to tweak it to make it be best for your application, and that's why it's so great.
mm.
And people need to realize that it's not just 4,000 psi. It's not just some strength out there. I know it's very common. I know most people that's what they get. That's what they got in school. It's, oh, what do you mean? It's 5,000 psi. That's just what it is. It's so much more than that. And if you
Yeah,
can learn to harness it, if you can learn to apply it, oh my God, think how much good you can do for
that's
your
awesome.
job and other people around you. So I can't think of a job in civil engineering, well, almost any job in civil engineering, where concrete wouldn't be valuable. You know what I mean?
I totally agree with you. Um, and to go along with that, I guess, as engineers that are out there in the industry, How can they help in this cause that you've talked about to make it more durable, to make it faster, cheaper? Is there ways for engineers to be more involved than maybe they currently are? Is it
Oh,
is
yeah.
it coming to seminars, coming to conferences? Is it participating in those things, or is there some ideas that you have that others could be way more involved with?
Yeah, no, I think that's an awesome question. I think continuous learning is always important, and continuous questioning and curiosity is always important. And so, if you've been doing something a long, long time, you should start to question it. For example, the three most common ways to measure concrete in the field to accept it are slump, strength, and air entrainment. That's what most people, when they think of concrete and actually accepting it, those three things are it. Air entrainment, the air content is the most recent one, 1949.
Yep.
1949.
1949.
That's when Walker developed the air meter. Okay, I mean that
We haven't improved that yet.
Well, there's improvements like the super air meter, and that's a technique that I developed that's getting out there. There's other improvements to those other tests, like slump is from like 1911, 1911, right? So there's ways, and you
It's
could say,
proven. It's proven.
well, it is, but sometimes there's, and I think slump is great for certain applications, but for others it's not. Like for slip form paving, it's not, and for 3D printing, I don't think it is.
Mhm.
And so you have to realize that some of these tools serve us, but there's a reason to sometimes update them. There's a reason to sometimes to look for something new. And I would just say, if you're an engineer that's using something that you inherited, you should know why you're using it.
I like
You
it.
should know why it's the number, it's the whatever. Because if you're not, you're just a robot. You're just copying from whatever came before you.
Yeah.
And if you know why, and you keep testing that, you keep looking into that, because we're learning all the time. People like me out there are trying to make things better all the time. And you can learn, maybe, is my old number still good? Or maybe does it need to change? So you can ask people, you can go to conferences. There's all these free webinars. You can go to my YouTube channel,
Yeah.
and I've got 300 videos on there all about concrete. And so you can start to learn and see if maybe you need to update a little bit. I think that's the most important thing that you can do. There's all kinds of resources out there. There's
Yeah.
all kinds of people out there. But if you're not willing to ask why, if you're not willing to get curious and look at your own business, you're always going to be the same. And nobody wants to be that, right? Nobody
Yep.
wants to be that person, or that whatever that is stuck. We all want to grow. We all want to give. We all want to change and do something different. You just got to figure out where you're comfortable at and where you want to contribute, because there's plenty of places out there. We'd be happy to have you.
I love it. Good advice. Well, this has been fun to talk about, Tyler. Thanks for doing this with me. Why don't you tell us a little bit more about your YouTube channel and the best way people can connect with you if they want to learn more?
Yeah. You can find my YouTube channel at youtube.com/Tyler Ley, TYLERLEY for Ley. Or you can just type in Tyler Ley YouTube. You'll find me. It's on there. I've got more than 80,000 subscribers. I've got more than 7 million or 6.5, 7 million views. And I get about 10,000 views every day on a good day. I get emails from all kinds of people from around the world contacted. If you want to follow me on Instagram at concrete.tyler, you can follow me there. And I'm on Facebook, but I don't check that as much. But Instagram, I'm somewhat active on, and you can find me if you want to. And yeah. So
And you teach.
I do. I'm
Go
a
take a
professor.
class.
You can come take a class if you want. And I get sometimes, all kinds of different people that we cross paths, and I'm happy to try to help you on your concrete journey if I can. And I'm on mine, baby. I'm running hard.
Love it. Well, thanks for doing this with me, Tyler. I really do appreciate it. It's been fun to do, and we'll catch you on another episode sometime, maybe.
That
Thanks
sounds
for doing
awesome,
this.
man.
See
Take care,
ya.
Isaac.